You ever stop and think about what's really going on inside your computer? I mean, you've got web browsers open, music playing, maybe you're typing an email, all at the same time. How does it not just, completely crash? Well, today, we're going to pull back the curtain on the real MVP, the unsung hero of your digital life, the operating system. All right, to really get this, let's use a metaphor. Imagine all your computer's hardware, the super powerful CPU, all that RAM, the speedy storage. Think of it all as a world-class orchestra. Every single component is a virtuoso musician, just waiting for their cue to do something amazing. You've got all this raw talent, all this incredible potential just sitting there. But here's the catch, right? All that potential is totally useless without some kind of coordination. An orchestra full of the best musicians in the world with no direction, that's not music, that's just noise. So the big question is, who's the conductor?
And that right there is your operating system. It's the unseen conductor that steps up to the podium and transforms all that potential chaos into a beautiful working symphony. It's the master coordinator making sure everything works together in perfect harmony.
So what does an operating system actually do? Well, the formal definition says it manages all the computer hardware and software resources, which, if you think about it, is exactly what our conductor does, managing the musicians, the instruments, and the sheet music to create a performance. It's the bedrock, the foundational software that literally everything else has to rely on. So let's talk about the conductor's first massive challenge, process management. Imagine you're not just listening to one piece of music. You've got your web browser going, a video game running, maybe a video editor rendering something in the background. For the OS, this is like having hundreds of musicians all demanding to play a solo at the exact same moment. How on earth does it handle that without creating total chaos? To get how this all works, we've got to understand the difference between a program and a process. The source material has this fantastic quote: "A program is passive, but a process is active." Okay, so what does that really mean in plain English? Think of it like this. A program that's just sitting on your hard drive, that's the sheet music. It's just a set of instructions, totally passive. A process, on the other hand, is the musician actually playing that music. It's an active, running program that needs the orchestra's resources, especially the CPU, right now. So how does our conductor give every single musician a turn? It's all done with this incredible sleight of hand called CPU scheduling, or you might hear it called time slicing. And it happens so mind-blowingly fast, you just don't see it. The conductor points to one musician, they play for a tiny fraction of a second, then bam, points to the next, and the next, and the next. This whole cycle repeats millions of times every single second. It creates this perfect illusion that everyone is playing at the same time. That's your multitasking in action. Okay, on to the conductor's next huge job: memory management. See, it's not enough to just let everyone play. You've got to give each musician the right sheet music. That's the data in your RAM. And maybe even more important, you have to make absolutely sure they don't accidentally start scribbling all over their neighbor's page. The way the OS pulls this off is with a brilliant security setup called dual mode operation. It creates two totally separate spaces, user mode and kernel mode. Think of user mode as the musician's personal space. A program running there can only see its own sheet music, its own memory. It's completely walled off. But kernel mode, that's the conductor's podium. The OS itself runs there, and it has full, privileged access to absolutely everything. This separation is what protects the core system from buggy programs. Now, any good conductor is obsessed with performance, right? They don't want any delays. Constantly having to run down to the giant music library in the basement for every single request would be super inefficient. So if the orchestra plays, say, Beethoven's Fifth every single night, what's the smart move? You guessed it. You keep a copy right there on the podium. In the computer world, we call this a cache. It's a small, incredibly fast bit of memory where the OS keeps copies of the data it uses all the time. This one simple idea, just keeping the important stuff closer, is one of the main reasons your computer feels so fast and snappy. Of course, what's a conductor without a music library? For your computer, that library is your storage drive, your SSD or hard drive. But a library is pretty useless if it's just a gigantic, messy pile of paper on the floor. You need a system, a catalog, and that is the job of the file system. So when you see a file on your screen, what does the operating system see? Well, it's way more than just the data inside. For the OS, every single file is a highly structured concept. It has a name, a very specific address telling it where to find it on the drive, a set of access rules saying who's allowed to touch it, and a consistent structure. The file system is the librarian that manages all of this for every single thing you've saved. Okay, but what about protecting the library from, a total disaster? Well, the OS has a trick for that called a RAID structure. The big idea here is redundancy. It's a clever way of storing extra backup musical notes across a few different locations. So if one of the library buildings, say, burns to the ground, no problem. The conductor can use those extra notes to perfectly rebuild any sheet music that was lost. The show, as they say, can go on. And that brings us to our conductor's final and maybe most important job of all, security and protection. They're not just directing the music, they are the head of security for the entire concert hall. This really gets to the heart of OS protection. The conductor, the OS, has to protect its own essential operations from programs that are buggy or even malicious. That's like protecting the symphony from a rogue musician. But it also has to keep the programs isolated from each other so that when one app crashes, it doesn't bring down your entire system. That's protecting the musicians from each other. So why is all this protection so absolutely vital? Simple. Because programming is really, really hard and people make mistakes. This famous quote, it's known as Kernighan's Law, just says it all perfectly. Even programs written with the best intentions can cause total chaos if they aren't kept in check. The OS can't just trust every program to behave. It has to be the strict enforcer of the rules to keep the entire performance running smoothly. So when you really put it all together, you realize that every single time you use your phone or your computer, there's this incredibly complex and beautiful symphony playing out in the background. It's all managed flawlessly by that unseen conductor, your operating system, which takes what could be total chaos and turns it into perfect harmony. And that just leaves us with one final thought. What new music are you going to ask it to play next?